Hello everyone, I am Professor Boyd from Union County College, and I would like to welcome you to the micro-lecture for working with like terms for basic algebraic expressions. To begin, the formal definition basically states that like terms have identical literal parts, or more casually, each term has the exact same variables with the exact same exponents. Let's take a look at an example. Here you're given an algebraic expression. First, either on paper or in your mind, separate and identify how many terms you are given by inserting imaginary boundary lines to the left of each plus or minus sign. You will notice this expression is now parceled into 6 terms. Next, to identify and emphasize the like terms, we will highlight all the terms with the exact same variables and the exact same exponents. To begin, we'll start on the left, looking at x cubed. Highlighting this in green, if we look at the remaining 5 terms, you'll notice that there's no other term containing an x cubed, so we're prepared to move on. Next, we have 8x squared, and looking down our list, the next term with an x squared will be 4x squared. Continuing, 16x is our term with only an x, and this, of course, will have a like term of 32x. Our last term, 64, is called a constant term. That is a term that only has a number in it. There is no variable. Since there are no other numbers in this expression, 64 will be its own term. The next step in simplifying algebraic expressions is to combine the like terms you have identified. This is actually a 2-step process where the first step will be to identify the like terms. The second step, which is actually the combining, is simply a matter of adding or subtracting the coefficients without changing the structure of the variables or the exponents. I'm going to warn you to be careful. Many students choose to overlook this identification process in the first step in the rush to complete the problem. The consequence often results in quite a bit of confusion and the frustration of doing algebra. It is better to work slowly and thoroughly and get a problem correct than to rush through and get the wrong answer. Returning to our previous example, the 6 terms have been separated and identified. Now, we are going to apply the concept that we can rearrange terms as long as we keep the plus or the minus sign with the number by reorganizing the terms in vertical stacks. So starting from the left, x cubed is its own term. There are no like terms, so it will be left alone. But now what we are going to do is move the 4x squared with the 8x squared. We're going to stack the 32x under the 16x and simply come along and slide over the 64. Now, to combine the terms, we are simply going to add down the columns. X cubed will just drop down. Adding 8x squared and 4x squared, the result will be 12x squared. Adding 16x plus 32x, the result is 48x. And again, since 64 does not have a like term, the result will simply drop down. In the end, we have our answer, x cubed plus 12x squared plus 48x plus 64. And one of the things I would like you to notice, which is very important, in this whole process, we never changed the values of the exponents. In fact, we left the exponents alone. The most common mistake that is found with combining like terms is the tendency to add the exponents along with the coefficients. So when we look at our problem, everyone usually has not too much trouble getting the problem set up, and the x cubed will drop. The common mistake that you will see is not only will 8 plus 4 be added to 12, but by mistake, you will add the exponents of 2 and 2 to 4. In a similar manner, the invisible exponent of 1 on the x will be added to an exponent of 2, giving you 48x squared. And then, of course, the 64 tends to drop. Be careful. You want to avoid this mistake. As you advance into more complicated algebra problems, this mistake of adding exponents when combining like terms will propagate into further mistakes, resulting in a wrong answer or possibly the inability to complete the problem.